to a BrightSpot Automation video tutorial. Today we're going to drop some objects onto a solar panel and see what happens with a BrightSpot electroluminescence camera that we have mounted here on the wall. So some of our customers have been asking us, we see these X cracks in the electroluminescence images on the cells. What causes those? Could it be hail impact from the front side, or is it something else? So we're going to take a ball bearing, we're going to drop it on first the back side of this panel with a transparent polymer back sheet. Then we're going to flip it over and try it on the glass side. So first, let's go and let's make sure that we're well focused. Let's turn on the power supply and enter video mode. And here you can see our solar panel. You can see that it's live. Here you can see my hand. And we're going to make sure that we're well focused. So we'll start out by setting the focus area about where we want to drop the ball. Focus over here and go autofocus. So now the software is controlling the motor of the lens, and it's stepping through a range of positions, mathematically analyzing each frame, figuring out where the best focus is. Then it's going back and doing a finer scale scan, and finally will be focused here in a second. You only need to do that exercise really once. Okay, so we're focused now. So now we're going to drop the ball somewhere around this area that's not too damaged already. So let's figure out where we are in space. Okay, so here's my hand. So let's try this area over here that's pretty much undamaged. I'm going to take that ball bearing less than a meter above the panel, and we're going to drop it and see what happens. So the impact was, I believe, around this region over here, but let's go drop another one, and then we'll take a good electroluminescence image. So let's drop over here. Here's the impact. And I do see some damage there, but it's a little bit hard to see in video mode, only 1/20th of a second. So let's stop the live view and let's go take an image here, a 4-second image. So now it's turning on the power supply for 4 seconds, and then it's going to enhance the image, enhance the contrast, and then do some perspective distortion and crop the dead area around the panel. So that is now popped up like there, and let's go to that area where I saw we dropped the ball, and indeed it did give an X-type crack in that region. There's another one where we dropped over there and previously over there. So that kind of tells you what happens when you drop from the rear side on the polymer back sheet. So now let's flip over the panel and do the same thing on the back side. So we're going to take the solar panel and we're going to flip it over. Alright, so it's pretty much in the same position as before. Let's now go in, start the power supply again, and enter video mode. Okay, so here we are, and we have some good region to work with over here, and should still be well focused. I don't think we need to refocus. And Let's take that same ball bearing as before. And let's go up at least as high, maybe a little bit higher, and see what happens. So 3, 2, 1. Somewhere over here. And I don't see anything having happened over there, but let's try it again. Three, two, one. Landed right here. And again, I don't see anything. Maybe let's go a little bit higher still. So about 1.5 meters this time. Landed right here. And I still don't see anything, but let's just take an image of this and make sure. So let's take another image. See the power supply going on for 4 seconds. And now it's going to enhance the image, remove the perspective distortion, enhance the contrast, crop the dark areas around. And here, we're looking for something having occurred over in this region, but I'm not seeing it. So, and that was pretty abusive drop. So, my conclusion here is that when people see X cracks on an EL image, it's probably more likely that it was something that occurred to impact the rear side of the polymer backsheet panel, not the front side, or it was maybe something that occurred prior to lamination, something that occurred in the factory. But probably X cracks forming in the field and front side impacts, not so likely. Alright, so no cracks yet from front side impacts. Let's go higher. We know that hail can cause cracks, at least dendritic cracks, very branching cracks, but let's go higher and see if we can do any damage to this. Hopefully we don't crack the glass. Here we're getting close to 2 meters tall. Ready? 3, 2, 1. Maybe it's somewhere around there. And again, I'm not seeing anything. All right, let's go even higher. Okay, we're gonna go closer to 2.5 meters tall. 3, 2, 1. We hit about right here. And so perhaps we need a bigger ball, but at least for this experiment, seems like it's much easier to cause X cracks from rear side impacts than from front side impacts. So we learned something here, but it's just really one test. We hope all our existing electroluminescence camera customers and future customers will do their own tests and share with us and the community what you learned. For more information, please visit our website at brightspoautomation.com. Thank you.